Hello and welcome to this video that goes through the AQA certificate in Further Maths Level 2. This is Specimen Paper 2. In this video we will go through questions 1 to 5. The first question says that a, b, c, d are consecutive integers. Explain why ab plus cd is always even. So to start off with, we can start with looking at the consecutive integers. So a, b, c, d. So for example, this could be 2, 3, 4, 5. Now, because it states that it's always even, let's have a look at whether, for example, these numbers are odd and even. So the first number here we've said is 2, that's an even number. B, the next number is odd, it's 3 in this case. C, the following number is even. And then D, the following number is odd. Now again, you could have picked any 4 numbers. You could start with odd, even. It doesn't matter for this question because they interchange with each other. So the first thing we have then is a times b. So in this case 2 times 3 is equal to 6. So a times b is even times odd, and this, as shown, gives you an even number. And then c times d is also even times odd, so therefore is an even number. So therefore you have ab plus cd, which is a even, plus an even, which is an even. And by showing these steps, so by showing that it goes a, b, c, d, so even, odd, and then even times odd equals even times odd equals even, and then adding two evens together, you have shown your explanation. So there's 3 marks here. The first mark for this one, second mark showing this, third mark showing that. And that gives you question 1. Question 2, work out the distance between the point A, 1, 4 and the B, 7, 12. So to work out the distance, you're going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, assign your points. You don't have to physically show this, but if you're struggling a little bit with this one, so you'll give point A, for example, assign it as point 1, so this is x1, y1, and give point B, let's say, is x2, y2. Again, it doesn't matter which one you choose as x1, y1 or x2, y2, as long as that point corresponds to a particular number. So both of these, it has to be the 1, both of these show the 2. Then just plug into your formula. So again, you're given a calculator, so it's very easy. So x2 minus x1 in our case is going to be 7 minus 1 squared, plus the next one, which is 12 minus 4 all squared. Plugging that directly into your calculator should give you root 100, which is equal to 10. So your answer here is equal to 10 units. Question 3, the nth term of a sequence is given by 3n plus 1 and 6n minus 5. Write down the first, 10th and 100th terms of the sequence. So from here, we start off with saying the first term is just n equals 1. So we just plug that in, 3 times 1 plus 1 divided by 6 times 1 minus 5, which is equal to 4 divided by 1, which is 4. So our first term is equal to 4. Then we plug in our 10th term, so n equals 10. So 3 times 10 plus 1 divided by 6 times 10 minus 5. So this one is 3 times 10 is 30, so it's going to be 31. 6 times 10 is 60, minus 5 is 35. So we can't simplify this one, so we're just going to write 31 over 35. And with the 100th term, it's 3 times 100 plus 1 divided by 6 times 100 minus 5. So it's going to be 3 times 100, which is 300, plus 1 is 301, and then 600 minus 5 is 595. So our answer here is 301 over 595, and that is part A. Part B, show that the limiting value of 3n plus 1 divided by 6n minus 5 is a half as n goes to infinity. So as n goes to infinity, essentially the 1 doesn't really matter. It is a very small part. If you've got 3 times a very large number, adding the 1 makes no difference. So therefore 3n plus 1 tends to go to 3n. We ignore the number here. And the same we can apply here. We can say, well, 6n minus 5, if you have a really, really large number, so 6 times a million, subtracting 5 is not going to make much difference to our number. So as n gets to infinity, we can say that 6n minus 5 tends to 6n. And then we can replace our values here, so as n goes to infinity, therefore 3n plus 1 over 6n minus 5 will tend to 3n over 6n, which is equal to a half. The n's cancel out, 3 divided by 6 is equal to a half. And that gives you your answer here. So remember, whenever you have n going to a very high number, we can ignore any numbers that we add or subtract to our value because they make very little difference to the overall number. Yes, it's a different number, but it's very, very close to the actual number. Question 4, the function fx is defined as fx equals x squared plus x. Write down the function of f7. So this simply is just the same as saying x is equal to 7. Notice here that the x and the 7 have interchanged. So in this case here, f of 7 is equal to 7 squared plus 7. So we replace the x here with 7. And that's just going to be 49 plus 7, which is equal to 56. So our answer here is 56. The next one, solve f of x equals 0. So we replace f of x in our equation with 0. So it becomes 0 equals x squared plus x. And from here we just do our usual factorising. So 0 is equal to x plus 1. So therefore x is equal to 0, or 0 equals x plus 1. So therefore x is equal to minus 1. So our solution is 0 and minus 1. Part C, write an expression for f of x plus 1 minus fx. So here we want to look at, first of all, let's just write in our fx. So fx is equal to x squared plus x. In our next step, we've replaced our x with x plus 1. So here our x squared goes to x plus 1 all squared, plus in bracket x plus 1. Again, all your x's have been replaced by x plus 1, so it's the whole of x plus 1 squared. From here we can expand out our terms, so it becomes x squared plus 2x plus 1 plus x plus 1, which we simplify to x squared. 2x plus x is 3x, 1 plus 1 is equal to 2. And then we plug it into our equation, so f of x plus 1 minus f of x. So it becomes x squared plus 3x plus 2, subtract x squared plus x. So x squared minus x squared is 0, 3x minus x is 2x, and then there's nothing subtracting the number. So it becomes 2x plus 2. So here, I suppose we can leave it as 2x plus 2, or you can factorise out the 2, so you get 2x plus 1. Both answers are accepted in this question. Part 5, a diagram shows triangle ABC, where AB is equal to AC. Show that the triangle ABC is equilateral. So here, if it's equilateral, it means that all the sides are the same. So first of all, we're going to say that AB equals AC. So if AB is equal to AC, AB is going to be 2x plus 3, and AC is equal to 4x minus 5. From here, we just rearrange, so we're going to add 5 to both sides, so 3 plus 5 is 8, and we're going to subtract 2x from both sides, so it becomes 2x. So therefore, divide both sides by 2, we're going to get 4 is equal to x. So again here, all we've done is plus 5, and minus 2x at the same time. From here, if AB equals AC, then therefore we can then say, well, 2 times 4 plus 3 is equal to 8 plus 3, which is 11, and 4 times 4 minus 5 is also equal to 11, and then we can test BC. So BC is equal to 3 times 4 minus 1, which is equal to 12 minus 1, which is 11. So therefore AB equals AC equals BC, so therefore it's 3 sides are the same, therefore an equilateral. Lateral triangle. And that brings to the end our question. It's 1 to 5 for this paper. Any further questions, please let me know.